Hello, in this video I will go over alternate series test and when to use it. I will also go over conditional and absolute convergence. So yeah, this is all about calculus 2 alternating series test. And yeah, let's go over this. So you're probably thinking, when should I use the alternating series test? If it's anything raised to the negative 1 raised to the or n plus 1. So yeah, if you have anything that's raised to the negative 1 raised to the n times a number, or negative 1 raised to the n plus 1, I think the key is negative 1 raised to an n, where the an is greater than 0, then the series converges. So the rule states if an is greater than 0, then the series converges if an is decreasing and the limit of n to infinity of an equals to 0. Okay, you know, if it is negative one raised to n, that is how you know you would use up. Yeah. So let me write this out. So if it's anything negative one raised to the n, that's how you know you would use the alternating series test. Okay. So let's go over the three steps of doing alternating series tests. Okay, so step one, decide if you can actually use the alternating series test. So if it's negative one raised to the n or negative one raised to the n plus one, you can use it. Step two, take out the alternating part and check to see if the remaining series is decreasing. What does that mean? I'll show you an example. If, oops, step three, if yes, then if yes, it is decreasing, then take the limit going to the infinity. If the limit equals to 0, then the series converges. If the limit does not equal to 0, then the series diverges. Okay, so let's do an example. Example one, determine if it converges or diverges. So we're definitely going to use the alternating series test because it's negative one raised to the n plus one. So step one, I'm going to pull out the alternating piece. So I'm going to factor out the negative one raised to the n plus one. And this is what you're left with. So now you're just left with this invisible 1 over n. Step two, plug in the limit as n approaches infinity. Into this. You get 1 over infinity, and what happens when you have 1 over a very large number? It becomes very close to 0. You want to, so yes, so if it equals to 0, you know it will converge. Yes, so you want this, if you can, that's good that you want it to get 0. And you know it will converge. Okay, step 3, by the alternate series test, it converges. That's my final answer. Okay, let's do another example. Let's do example 2. Okay, so we have a summation from n equals 1 to infinity of -1 raised to the n times n squared over n squared plus 5. So can we use the alternate series test? Yes, we can, because I see a -1 raised to the n. So first step, pull out the alternative piece. Step 2, plug in n to infinity. Okay, so when you plug in infinity, infinity squared is infinity. Infinity plus 5 is still infinity. What's infinity over infinity? Usually 1, and that does not equal to 0. So it's going to diverge. Okay, let's do example 3. So we have the summation from n to infinity of -1 raised to the n minus 3 times square root of n all over n plus 4. So can we use the alternating series test? Yes, because it's -1 raised to the n. Now, be careful. Do you see this -1 raised to the n minus 3? It's something you need. This is a little review. I'm going to review something. if you have a raised to the n plus m, that is very simple. That's equal to an times an, right? So it's the same thing with this rule right here. So if we want to, we can rewrite this as, and then, yeah, we can rewrite -1 raised to the n minus 3 as -1 raised to the n times -1 raised to the -3 times square root of n. I think it'll make it much easier. And then n plus 4. Uh, and what else do we know? We have, so yeah, maybe what we should do, I don't think, let's just take out the step one, pull out the alternating part. So the alternating part is -1 raised to the n minus 3. And then you're left with square root of n over n plus 4. Step two, plug in your limit as n goes to infinity. So you're left with square root of n over n plus 4. And if you want, you can rewrite square root of n as n to the 1/2. So how do we find the limit? So this is a rational function, and when the limit is the horizontal. So what is your rule? So you pick the highest term on the numerator and the highest term on the bottom. So your highest term on the numerator is n to the 1/2. Your highest term on the bottom is n to the power of 1. So what is this? Is this top heavy, bottom heavy, or the degrees are the same? It is technically bottom heavy, right? So when it's, yeah, bottom heavy, you know the horizontal asymptote is at y equals 0. So we know it's if it equals to 0, it's going to converge. Okay, now let's talk about conditional and absolute convergence, uh, fixed and alternating series. Okay, so conditional, absolute, convergence, fixed, and alternating series. So conditional if the summation of -1 raised to the n times an or equals, or the summation of -1 raised to the n plus 1 times an converges, but the summation of the absolute value of -1 raised to the n, -1 raised to the n times an, or the summation of the absolute value of -1 raised to the n plus 1 times an diverges. So what does that mean? So absolute if the summation from -1 raised to the n times a of n, or the summation of -1 raised to the n plus 1 times a n converges, and the summation of absolute value of -1 raised to the n times a n absolute value, or the summation of the absolute value of -1 raised to the n plus 1 times a of n converges. So let's do an example. Yeah, determine conditional or absolute convergence for the series. So what we're going to do, I think it's pretty much the same rule. The only difference is we just put the absolute value. That's really the main difference. So step one, we have this series, as n the summation of n goes to 1, n equals 1 to infinity of -1 raised to n over n. So step one, pull out we definitely use alternating series. So go ahead and pull it out. Okay, this. So you're left with 1 over n. Step two, as the limit goes to infinity, plug in your limit as n goes to infinity. Okay. You plug in n for infinity, you get 1 over infinity, which is equal to 0. So we know it converges. Okay, so that's that is for the alternate part. Now remove the alternate part and check for absolute convergence. So now what we're going to do is check for absolute value of our series. That's where you put the absolute value sign. So okay, so we took out the alternating part, so it's really just so just remember when you take the absolute value, anything in an absolute value, it makes it positive. When we took out the alternate part, we get this, right? 1 over n. That was our leftover. Now, it's no longer alternating because it's not -1 raised to n. So that means we have to choose another test. Since it's not alternating. So what you can do is, test shall we use? we'll use the riddle NPGCITA. Nice penguins go camping in the Arctic. That's like a little riddle you can use to figure out which what test you can use. So N P G C. So it's nice penguins go camping in the Arctic. So we can't use the N. Can we use the P stands for P series? So I think it is a P series. So it's a P series. So the test, we can use the P series. So um, I believe our P is going to be 1, right? So if our, yeah, we're going to use a P series. And then if our P is equal to 1, because this is n raised to the 1, it's still technically less than equal to 1. So we know it diverges. If both converges and diverge, it's both a converge and diverge. So remember when we took the first test, it converges, and then we took the second test using the P series, it diverges. If you have both, that means it's a conditional type, conditional diverge. So this is a conditional convergence because it was both a convergence and a diverge. So because it's like both a convergence and divergence is a conditional convergence. Okay, now let's do another one. Let's determine if it's a conditional or an absolute convergence for the series. Okay, so determining conditional or absolute convergence for the series, we have the summation from n equals 1 to infinity of negative 1 raised to the n all over n squared. So first, it's definitely an alternating series test. So first take out the alternate part. So we have negative 1 raised to the n, and you are left with 1 over n squared. Step 2, plug in the limit as n goes to infinity. So when you plug in that, that's 1 over infinity. That's 1 over infinity or equals to 0. Since it's bottom heavy, it converges. Okay. So that is the alternate part. Now, what you got to do is try the absolute value ways. Okay, so how do we do that? We're going to rewrite this as summation as n goes to infinity, negative 1 raised to the n over n squared. And when we took out the alternate part, you're left with this. So the absolute value makes it positive. So over here we have 1 over n squared. Is this it's no longer an alternate. It's no longer an alternating series test. You can't use the alternate because it's not no longer negative 1 raised to the n. So you're gonna have to use another test. Okay. So let's use the riddle nice penguin NPGCITA. We can't use the n. Is it a P series? I think so. It's definitely a P series. So we have this. And I believe our P is going to be 2, which is greater than 1. So we know it converges. So what did we have before? When we did the alternating part, it converges. And then when we did the absolute value, it converges. We have 2 converges from the alternating series and P series test, so it's an absolute convergence. So our final answer, yeah, because we have 2 convergence, it's now going to be absolutely convergent. Okay, so yeah, that wraps it up for this section. I'm going to stop here.